Welcome to 3ds Max Design Basics, Episode 1. In this tutorial, we'll go over the basics of 3D modeling. Also, we will cover the interface of 3ds Max Design, file management, and basic modeling and animation. My name is Ronnie Lanham. I have been teaching 3ds Max for 6 years and working in 3D in one form or another since 2000. 3ds Max Design is the version of 3ds Max geared towards drafting, design, and visualization. The key here is realism rather than a more aesthetic final product. In reality, there aren't very many differences between the two flavors of Max. Some of the key differences are the default renderer and the fact that Max Design has a lighting analysis feature. What you see here is the default visual theme for each of the two user interfaces. By default, the standard version of Max has the dark interface favored by creatives. Max Design uses the original light UI. Both programs allow the user to change the UI to either the dark or light versions. By default, Max Design uses the Mental Ray render engine. This is the basis for the render engines in Revit and Inventor, only here you have much more options. Max Standard uses the original Scanline render engine. Again, this can be changed in either version. Max Design's Object Properties options default to by layer, which maintains a workflow similar to AutoCAD. For example, if you want to freeze or hide an object, you must freeze or hide the entire layer on which it exists. The standard version of Max defaults to by object, which means that each object has its own properties. This feature can be changed back and forth in either version. The final key difference is the lighting analysis feature in 3ds Max Design. This feature does not exist in the standard version of Max. This feature allows you to test how various lighting schemes affect your models. It is beyond the scope of this tutorial to cover this here, but perhaps we will cover it in a later episode. If you remember Cartesian coordinates, you locate the position of an object in space by x, y, and z coordinates. A vertex is the simplest part of a computer model. If you noted when I selected the vertex, the coordinates panel shows its position in x, y, and z. Two connected vertices form an edge. Three or more connected edges form a polygon, also known as a face. In 3D modeling, there are three basic types of polygons: triangles, quads, and n-gons. N-gons should be avoided if possible because they can cause problems with certain modeling techniques. Each face is infinitely thin, so it has what we call a normal. The normal is simply the direction from which we can see the face. This aspect of faces brings us to rendering. Once we have our 3D model, it is still just a bunch of points in virtual space. For us to be able to use them effectively, our scenes need to be rendered. Rendering takes the 3D model and creates a 2D image that can be viewed like a photograph or a series of images put together that can be viewed as an animation. At this stage, 3ds Max tells the computer to calculate the image using materials, textures, lighting, and animation. As I mentioned earlier, faces are infinitely thin and have a normal that shows which side will be visible to the camera. If we render the face from any other side than the normal, the polygon will disappear. The 3ds Max interface is broken up into different sections to help you navigate. At the top left of the interface, we have the tools that we will use most often. The large M represents the application menu. This is where you find the standard file options such as New, Open, Save, Save As, etc. Of particular note for new users should be the Manage menu. We will cover this in depth in the file manipulation section of this tutorial. Next to the application menu, we have the quick access bar. This does exactly what the name says. It gives you quick access to frequently used commands. Below the quick access menu are the standard drop-down menus that almost every program has. We will cover them as we go over specific tools. Finally, we get to the main toolbar. These are the tools used most often. Like the interface as a whole, the main toolbar is broken down into sections to make it easier to work with. At the far left of the main toolbar are the link tools. These allow you to create assemblies of objects that are connected to each other but can also move independently. Next to the link tools are the select and transform tools. The first four buttons are the selection tools. The select object tool allows you to directly select an object by clicking on it. The Select by Name tool opens a list of the objects in the scene. With this, you can select multiple objects, use the Find feature to narrow your search, and also filter the selection by type. This menu brings up two important parts of 3D modeling. Always name the objects you create and name them something descriptive. If you are working with a scene that only has a few objects, this may not be as important. However, as soon as you start working with scenes that have thousands of objects, and you have to search through a list populated with names like Sphere 001, Sphere 002, Sphere 003, etc., you will wish you had named them. We will go over how to name objects later. The last two select tools apply to the direct select method. The selection region button allows you to pick a shape that the selection tool will use if you click and drag out a selection. The window crossing button changes how the selections are made. With the option on, the selection region will only select objects that are completely within the region. With the tool off, it will select any object that the region touches, even if it is not completely inside of it. The better way of handling selections is to enable these features in the Customize menu. Go to Customize, Preferences, and look for the Scene Selection area of the General tab. Turn on Auto Window Crossing by direction. By default, if you drag the selection window from right to left, it will select anything it crosses. If you drag from left to right, it will only select objects that are completely within the selection region. This makes Macs behave more like AutoCAD. Next to the selection tools are the transform tools. These allow you to move, rotate, and scale objects in the scene. Each tool has its own reference coordinate system, or RCS. The default RCS is View, and it changes depending on which view you are working in. This can make things difficult after a while. The more useful of these options are the world and local coordinate system. Generally, I use world 90% of the time and local when I am animating an object. Remember, though, that you have to change the RCS for each of the transform tools separately. We will go over the RCS in a later tutorial. Okay, we're running long and we're pretty close to the 10-minute mark, so I'm going to call this part done, and be sure to tune in for part 2 later on. Thank you.